to see you all. Congratulations on getting through 3 weeks. It's great, especially for those of you who are housed in the famous HIE, as we call it. And 3 weeks, hopefully going home is a comfortable experience for you and getting out of the holiday. And we're just delighted that this is our 5th Bioscience Industrial Fellows Program. This is sponsored by the National Science Foundation's Advanced Technological Education Program. And this class actually represents approximately 50 people going through the class. So as today, as you make your presentations and you actually graduate as fellows, you become part of 50 other people, across the country that have come through this program. And so we're really excited. So first of all, I want to say congratulations to each one of you. Yesterday we took a little poll after we finished a talk on intellectual property by Dr. Michael Battaglia. We took a little poll, and just to show you on that card, those are expressions from you guys as to what you thought you felt going through the program. And we tend to do that every year. That's something we like to do. And at the same time, we like to thank everybody we've seen. And I'm going to kind of show you some real quick slides to show you kind of how the program has unfolded. But I really want to give you guys a tremendous acknowledgement for your professionalism. I've done this program 5 years with Denise, and we're never too sure how the group is going to come together in terms of teamwork and dynamics. And I've got to say, right from the very beginning, you guys glued together really well. And it's extremely important. Alan's just come in. You met Alan at the beginning, Dr. Alan Murdoch, our Vice President of Economic and Workforce Development. A lot of you probably don't know that Alan actually did his doctorate in partnerships. And so we're big on partnerships here, but we're big actually on the theory of partnerships, but also the practice of partnerships. And I think what you guys did was you really illustrated to our partners in this program, and I'm going to show you how many partners we actually have, the value of partnership. And your behavior was exemplary. And that was really important because we go back to them next year and ask them if we can come back. And so the partnership is dynamic, it works both ways. What's in it for them is they're going to get your students eventually as workers, right? Whether they be scientists. You saw the gambit that we saw in the past 3 weeks, so there are many, many jobs within biosciences. And it's not necessarily on the bench or in the clinic, but it's somewhere in between, and it's along that supply chain. So there's a lot. So I thank you for your behavior. It's really, really good and really important. Just want to review with you what we do here at the National Center for the Biotechnology Workforce. Essentially, we try to interpret the needs of bioscience companies and put that into some format of being able to relate that back to our other colleagues with whom we work with right across the country. Deb is a really good example of that, actually. We just came back from a meeting from San Francisco where we were with another sister organization, BioLink. So we share best practices. We actually publish them, as do other centers and projects, up on our website at biotechworkforce.org. I think I mentioned the partnership part, but you all now are partners to us, and that includes obviously everybody that's in this room, because it's a perpetual thing, right? So we heard from people over the past 3 weeks, people having access to supplies and people not having access to supplies. And so as a group together, you kind of have an obligation, if you want, to make sure that everybody has a fair shot at getting a good STEM education and getting the supplies that they would need in order to do that. And I think Tiffany spoke up a couple times during the 3 weeks to some of the employers that we visited and said, I literally can't run a lab because I don't have any funds to do that. So I think your case was made well, and I think you made the case to the right people, Tiffany. but as a group, as you go back out into your classrooms, back to your colleges, wherever your labs, think about that and think in the back of your mind, hey, is there anything I can do to help? And also that might mean a future grant possibility. That's exactly what we've done for the last 14 years. We've leveraged those partnerships to make sure that we have people to work with. Most recently in the past 2 years, we brought Jason into the family, and he's done a great job with the Analytical and Molecular Skills Lab, and I think you had an opportunity to witness that at the beginning of the Fellows Program this year. And Jason is a resource, so a lot of you have actually even emailed him and decided that going forward, if there's opportunities to work with the lab, and we encourage that. Okay. So what were we trying to do here? So just I have already mentioned we're National Science Foundation for Advanced Technological Education. You did the 3 weeks, that. You were immersed into boot camps. Really pleased with how the boot camps went, and I think the proof is in the pudding. It's up to you to report back to us whether or not you enjoyed those boot camps. But I think we delivered. I might be wrong, but I'm hopeful, Amy, that we delivered. Okay, and I feel really good about it. And it's up for you to decide now whether or not you've got a very valuable experience or not. But from all the observations that I saw, actually, if you take, like a very seasoned, trying to look for a good word to use for me, but somebody who's been in the industry for upwards to many years, I'm not going to say how many, every time I go to a fellows program, I learn so much. And it's not just necessarily learning from you, but it's also learning from those visits that you're being a part of. Here are the visits that we made this year. And I'm not going to name them all, but you experienced them, you knew them, but the bottom line here is we saw some very big pharma, and they were very gracious to invite you in, to show you what they had. At the same time, we went to colleges, we went to research parks, we went to small pharma, we went to biopharma, we went to vaccines. So we had a huge array and variety of experiences. And some of those, I'm sure, are resonating in the back of your mind as to how you may go forward and may work with them. So that's them, and we'll make these slides available, but you have those in your booklets anyways. But I've just seen Bill Woodruff come in here. This is Bill's 5th BIFP graduation, and as it is for Denise as well. It just amazes me that I actually see, I see a motivation in the instructors. So they get very excited when they see you. And we actually heard that on a couple of occasions. Patty, didn't we not? We heard that. They said, oh, we really get excited when the fellows come. So that's great. So what happens next? So we'll need a copy of your presentation today. We'll bundle that presentation into a PDF. We'll upload that to biotechworkforce.org. We'll share it with our other NSF people to make sure that it's widely distributed. Amy will be interviewing you. And
survey first, yeah. Survey, and the next 2 weeks you send to you.
Survey and then an interview. And we want you to go back to your institutions. And if you read the protocol, we actually ask you to go back and share this in a professional development capacity, so with your colleagues. So Nakeisha, you'll be up for that, and that'll happen here. And we have a professional development day, so we'll look forward for you to participate and do that. And at the same time, I've already mentioned partnership, but also we want you to keep in touch with us. Okay, that's really vital. It's important. You're now part of the family. So I'm just going to quickly say thank you on behalf of Denise and myself. Denise, do you have a comment or two you want to make?
I just add congratulations. I know from our boot camp that this was a great group, and I'm sure you've worked very hard the last weeks, and I'm anxious to see what you can do.
Thanks, Denise. Amy, any other comments?
No, just looking forward to it. Yeah, there was just a lot of energy. I mentioned that first morning, y'all were probably meeting each other that first morning, but there was a lot of great energy, so this is exciting to be here.
So I'm going to point to the boss now and ask the boss if he might have a comment or two that he wants to
Sure. Well, congratulations, you're done, right? Almost. These are positive exit interviews, is that correct? So who's going home today? Everyone find out tonight? So starting tomorrow, you gotta make your own bed again, right? I told you that. 3 weeks? 3 weeks? Has it been that long? 3 weeks?
3 weeks.
Wow, 3 weeks gone by quick. I didn't see you guys one time. Russ did keep me up to date on some of the stuff you guys are doing. He's really, it kind of threw me for a little bit of a loop because he had such positive things to say about you. And I was like, what happened in past classes then? It was something I should be informed about, but no. He was excited to have you guys, and I think he's looking forward to another year of this. We got funded for another year, correct? So if you can help us out with that, so if you know somebody that could benefit from this, that would be great. And like I told you 3 weeks ago, I hope you got a lot out of this. I hope you enjoyed it, or hope you learned something. Not that you weren't smart coming in, but I hope it's stuff that you can actually pass on to somebody else. Because that's why we're here. It's not about Russ or myself, or even you guys, I'm sorry to say. The students that we're working with, and to help them make better decisions, get excited about the cool things that are out there. So let me just ask you a quick question. What was the coolest thing you saw out there? And I was never a school teacher, but I don't have a problem pointing on people. If you're wearing a bow tie, you're stuck, man. You're the chicken farmer, right?
Yeah.
All right. You have a chicken tractor?
I do, actually.
Is it from me?
No.
No? Because I have a class building chicken tractors, so I was just curious. Okay. So what was the cool thing, man?
Nobody's had some really interesting stuff.
Scary, isn't it?
Yeah, very. But it's enticing, and it definitely motivates us to get ready for the future and what's to come down the pipeline.
And it's funny, in the future, you could actually probably hit it with a rock from here.
Yeah.
Really? It's just right around the corner. All right. That's awesome. How about anyone else? Something cool you can't wait to share with your friends, family, students? Yes?
Just the scale at Biogen of their bioreactors and how much they're actually producing. I can't visualize 15,000 liters until I see a 3-story tall bioreactor, and it just kind of
Sorry. I made that big mistake earlier. Okay.
To really kind of expose my students to everything. We tend to do it in small scale to show them that this is what it ends up.
So 15,000 liters is big.
3-story tall bioreactor.
Did you tell them about Biogen?
Yeah.
And my relationship to Biogen?
Yes. No, I did tell him. Go ahead, tell him.
So I used to work in Charlotte, and when Biogen first came here, it actually had a different name. But, I was working underneath our economic development media person. So the economic development media person films commercials for companies and such. Biogen wanted life-size cardboard cutouts of people wearing their uniforms. And since I was happening to be around, I became a model. And supposedly my cardboard cutout toured East Coast colleges for about 3 or 4 years. It now sits in my house and scares the hell out of my dog. That's the only tie I have to Biogen. Anyone else? Something cool you want to talk about? I know it's Friday. Yeah.
I was impressed from the very beginning with what seems to be very close collaboration between educational entities, academia, industry, the state government here in North Carolina, and I'm hoping eventually we can get to where you guys are in Texas.
In some regards, I'd say Texas may be ahead of us, actually. But I want to say that those are hard-fought partnerships. They don't happen overnight. But if you have people like Russ that are really looking at it not for himself, but for others, we can get there. There's a huge plus there. But those are long, drawn-out battle lines. I just came back from Williamsburg. Yeah, that's a good analogy for state government partnerships.
The Carolina Bio Network with all the resources for educators is, that's really impressive.
Yep.
I plan to use any of them.
Good, good. Yep.
Working with the CHO cells and Dr. Winter's lab was interesting because when we went to Biogen, someone asked, what are the cells that the line you guys are working with, and they said CHO cells, so that was interesting.
You're already connecting dots. Perfect, perfect. Yeah.
I'm very impressed with the older community colleges here. Older community colleges with fully equipped labs and instructors. It just, from where I come from, your state, like we don't even have community colleges that advanced.
Yeah, I think we did that because we were trying to get ahead of the curve. Well, we were a big manufacturer, right? And that kind of disappeared, so what's next? And so we had a lot of people invest into the sciences. You guys went to Roland Cabarrus area, you saw that lab there. Is that your lab? All right, have you met Murdoch?
Yes.
So, let me tell you about Murdoch. If you were to, I met him one time at a retreat at Pinehurst with the Charlotte Chamber, and he's a pretty cool guy, right? So he's kind of started off with nothing and made his way up and owns like Whole Foods and all that stuff down there. And he starts off his conversation saying, you know what? I am probably the dumbest person in this room. So I dropped out of school in the 6th grade. Yeah, well, we all end up owning a multi-billion-dollar company by being the dumbest person in the room. But he's an interesting guy. You know, there's always these stories behind that. And because of him and others that have just, say, infused money into North Carolina, we're reaping the benefits of that. So our hope is that we'll be able to recruit more bio companies in the near future. You guys probably spent some time down in Raleigh, right, which is kind of our center point for bio in North Carolina. We'd like to do the same thing up here. Maybe not the same scale because I think they had a 60-year jump on us starting off, but you know, we're making our way. You saw W Firm, you probably saw a few other companies here, and now we have us here as well. So I think there'll be some pluses moving forward in North Carolina in the next couple of years. Does anyone want to come back here for a vacation for you out-of-staters? We can always use your economic development dollars. We're always looking to take your cash. Where are you from, man?
California.
California. Oh, yeah, we'll definitely take your cash. Just come on down. You don't want to move here for a job? You know, we have better equipment than yours does. Just so you know. Anything else anyone want to share? I'd rather hang out with you guys. I have employee issues I got to deal with after this, but you know. All right. Well, thank you. Oh, I had a question. How did my team treat you? Ross, they're all right? Everything kind of moved, clockwork, everything's okay? Hotel's all right? Got you safely from one place to the other? No speeding? This is NASCAR country. Just checking, just checking. You guys have a safe trip home. Thank you for participating. I hope you got a heck of a lot out of this. And please, one of the things we struggle with every year is getting people into this group. It's been easier as the years have gone by because people understand there's value here. But if we could fill this thing out by November of this year for next summer, that would make my life and his life a whole heck of a lot easier. Any questions for me before I take off on you? No? You guys
I have a question.
Sure.
Are you related to Mr. Murdoch?
No.
We all asked this question the other day.
Yeah, I'm one of the poorer Murdochs. So, like you had Murdoch that owns Dole, and then you had Rupert that owns like that newspaper in Australia and several other things. And there's me that owns a house down the street and a dog, and that's about it.
And a cardboard cutout.
And a cardboard cutout of myself in Biogen attire, carrying a green folder, which is, you know, always a plus. All right, folks, you guys have a good one, and safe travels.
Thank you.
Thanks, Russ. Okay.
So Alan has been a great supporter of this program and a great supporter of what we have here at the Innovation Corner. So we're really excited. So we have the teams now coming in, right, Patty?
Sir.
So we have Team A is Deb and Stacy. Come on down, as they say.
good morning. Thank you everybody for coming out and listening to us today, and everybody online. Hi. My name is Stacy Deaver. I have a master's degree in animal science, and I am an assistant professor at Virginia Western Community College. I teach our biotech classes, cell bio, anatomy and physiology, and gen bio.
I'm Deborah Overath. I have a PhD in genetics, and I teach mainly biology at Texas Southmost College in Brownsville, Texas. The name is indicative. I'll show you on a map. We are Southmost. And I love it there, and actually I'm going to be starting this fall working towards building our own biotech program, so this was a great opportunity to learn a lot of things that I can incorporate into that program.
So we entitled our talk, Why Do I Need to Know This? A 3-week case study on bioscience industry and academia. When we started thinking about this whole process, there are 2 things that kind of came up for us. How do we figure out what North Carolina is doing right to take it back to our states? And how do we convince our students that they need to care about everything that we learned about while we were here? So we're going to start with just a basic overview of biotech.
So this slide that Stacy found for us gives you a snapshot or a picture of the different areas that go into biotech. See this figure here, everything from chemistry, pharmaceuticals, even information technology, and it gets into smaller areas. But so it shows the breadth and variety of biotech. But I also wanted to point out there are some things that aren't on here that we learned about. Like every company we went to, they talked about, there's things outside of STEM that we need workers for. HR, accounting. We learned about intellectual property yesterday. There are folks that work in those areas. And so one of the things we want to do is bring back to our students an appreciation of the variety and depth of biotechnology, and that even if you have some interest in STEM, but your strong interest is something else, you may still end up in a career in the biotech industry or something related to the biotech industry.
All right, so I just want to do a quick overview of Virginia. We do have a local trade organization, Virginia Bio. They've apparently been around for 25 years, but it's only in the last 3 to 4 years that they've actually started to kind of grow and get things going. And I actually had the pleasure of going up for our first, I guess it was a workforce summit between industry and academia. I had to take one day away and go up there. And it was a really good conversation. I think we're finally starting to start down that path of how do we merge the two and get bioscience growing in Virginia. They have some really interesting events. So Virginia Beach has their own group called Virginia Beach Bio. They've actually started a women building bio event. So around the states, they actually bring in females, everything from CEOs to lab assistants, to come together and kind of talk about how to promote women in STEM and women in bioscience. Down where I'm from in Southwest Virginia, they have the Life Science Forum. What I love about this is that it is probably the most friendly environment I've ever been in for bioscience. It's hosted either at Virginia Tech down in Blacksburg or the Research Institute up in Roanoke. And we have students present their research there. So they're welcoming of everybody. It's a very inclusive environment, and I think it's starting to promote the area. A little bit about life science in Virginia. We have a couple of different corridors here. There's one that's focused around the Hampton Roads area, Northern Virginia. That's what most people think of when they think of bioscience in Virginia. A couple of smaller clusters in Richmond and Charlottesville. I'm going to take this thing out, I'm sorry. And then the 81 corridor, which is where we're really trying to grow bioscience. We're a huge textiles area and farming, and without leaving, we need to find something else. What I found really encouraging, so this data was actually just released about a month ago for us. We're seeing a huge increase in the number of establishments. So we've had a 15.5% increase in the last 2 years in bioscience establishments in Virginia. So that screams startup to me. I couldn't get the breakdown of the different industries. And also we have a projected 8% growth per year in bioscience until 2026. So I think we're going down the right path with that. Currently, research, testing, and medical labs are our biggest industry, and that's a lot of the colleges, it really is, as well as pharmaceutical production. What I found interesting was ag, feedstock, and chemical production is only 1% of our bioscience industry, and yet it is the largest industry in Virginia. It provides about $70 billion in revenue a year. So how do we fix that disconnect? And then a couple of the companies, we have a lot of them that we heard about while we were here, things like Merck, Grifols, Novozymes. There's actually an office right outside of Blacksburg and Salem, but also a lot of smaller startups that are really interesting. I just learned about HemoShear this week. They're actually looking at children's rare metabolic disorders, trying to find cures for that. So they're focusing on the rare disorders, which is kind of interesting. Polymer Solutions is basically a CRO. They do any contract work that you can want. And then Virginia Tech Petroleum Research Institute, if anybody knows Mike Friedlander, he came to us and is now starting a huge research institute focused on neuro and cardio primarily.
So I'm now going to do the same for Texas, give you a little flavor of what we have. Our main trade organization, we've already figured out it doesn't work. Our major trade organization is the Texas Healthcare and Bioscience Institute, and this is a place actually where industry, academia, and government kind of come together for the state. Then there are also some more local areas, so Austin, Houston, San Antonio, and North Texas, which is mainly in the Dallas-Fort Worth area, have their own separate trade organizations, although some of these are actually, if you look at them more closely, they're really more coming out of research institutions rather than the industry themselves, but they do connect with industry. As you'll see, and you might guess, from the fact that trade organization is Texas Healthcare and Bioscience, we have a pretty strong biomed component. So in Texas, we are seeing growth. My numbers are a little bit older than Stacy's. Our numbers haven't been updated yet. So this is from a report that came out in 2006. But you can see that pharmaceutical products, drug and pharmaceuticals, are the fastest growing segment. I just wanted to give you an idea of some of the things that are actually produced in Texas. Opti-free lens care, different vitamins, and so forth. So we are producing some of these things right in Texas, but the largest employers, we sort of flip-flop from Virginia. If we look at the pie graph here, our biggest area is bioscience-related distribution, and second is the research and testing. And I was like, what the heck is that? So I did a little investigation and found out that bioscience-related distribution, as the name implies, is distributing bioscience products. Although apparently now they're also getting into higher tech things such as cold storage. A lot of the biologics that we've seen and talked about at some of the companies we went to, they need to be refrigerated, right? So cold storage and also monitoring some of those highly regulated products that they need to be of a certain quality, and if they fall below that quality, then they have to be discarded. So those are areas that fall under this bioscience-related distribution. I also wanted to point out, like Stacy, ag is huge in Texas. Texas is third in the country for agricultural products. We're #1 for cotton and cattle, as you might guess, but we're still single digits for agricultural feedstock and chemical bioscience, biotech-related industry. So that's an area also that I think we can grow in. One thing that's not on here and we haven't seen and you don't see here, so these are some of the leading life sciences companies in Texas, some of the names you'll recognize. One of the things that I noticed is sort of left out of this are food production and beverage production of beer and wine. Yes, we make good beer in Texas and pretty decent wine. And just food production in general. When you think about dairy products or other products that probably need to be produced in clean rooms very similar to some of the industry places we visited. And they need to be tested to make sure, so think of yogurt, make sure something that shouldn't be in the yogurt isn't in there, right? And we periodically get scares of things are contaminated with listeria or E. coli. So those are areas also where biotech technicians, bioscience technicians can find employment and sort of left out some of these discussions. Another area, or another thing I wanted to point out, if we go back, let's go back here for a second. The 3 areas here in Texas where there's a lot of biotech are in the Houston area here, Central Texas, Austin and San Antonio, and then North Texas, Dallas, Fort Worth, and then a smattering of other places. Brownsville and the lower Rio Grande Valley, right down here, right, southmost. And you don't see any lines pointing there. But if we look here on this next slide, I mentioned biomedical is important. We can see a lot of the big universities are opening new research centers and biomedical research centers and new medical schools. And we've got several now in the lower Rio Grande Valley. And so I think that's another area that we could capitalize on in my region to get ahead and focus some of our training.
So that was kind of our takeaway from an industry perspective of what can we bring to our state, what can we bring to our administrators to help them understand why we need to be doing this. The other side of things, and what I'm really excited about, is why would I have to take this class that's not in my major? Every college student ever has probably said that at some point in time, right? And so for us, a big takeaway was that you're not just going to be a scientist. You're going to have to interact with other people. You're going to have to, have a wide variety of skills. And that bioscience and STEM, it's not this little silo anymore that we exist in. We have to kind of broaden our knowledge base, right? The other thing is that not all science majors will want to be scientists, and not, I should say, in other majors may want to have a role in science. I had a student in my cell bio class who convinced him to take cell biology. He's a business major. Our cell bio is a major's level science class, but now he's actually thinking about going into the pharmaceutical industry from the business side of things. He really got excited about the science, even though it's not his primary focus. And then also, me personally, my goal as an educator is to create a community member who can contribute. I think that's, as every educator, that's something that we need to think about. So what we did was we highlighted some of the topics that we learned about. So math, not just for accountants, right? Throughout this whole time, everywhere we went, there was math embedded somewhere in the topic that we were exploring. So at Rowan Cabrera's, we did some GC mass spec, and we had to plot a standard curve and then use the equation that was generated to identify unknown concentrations, right? So if you don't know basics about graphing and slope and those types of concepts, you're not going to be successful. When we were at BTech, you guys had to do dilutions of your GFP to figure out, different concentrations and things like that. When we were at Alamance, chemocytometry and figuring out cell concentrations and then figuring out how to dilute those into the appropriate concentration that we needed. So I know personally my students hate lab math. They see it every day. I don't let them ever forget it. But it's something that is sort of an underpinning to all of our fields. And so what we've done is we're going to talk about a topic, and then we went out and found jobs that highlight that particular skill set. All right. So here, this is the director of rare disease statistics person. This is a Pfizer job description. Provide scientifically rigorous statistical input into project development plans, regulatory submission and questions, interpretation of statistical results, study design, all about math, right? So biopharma, big biopharma needs stats, so you're gonna have positions that have math in them. The next topic, English. Let's eat grandma versus let's eat grandma. Punctuation saves lives, right? You have to have a basic understanding of English in order to be able to, A, communicate with your colleagues, but also read something like your protocol, right? Following directions and being able to read that protocol is essential. When we were at Carolina Biological, we learned that they have people who write protocols for faculty and for instructors, right? So again, here, this is a scientific writing position from Wake Forest. I found this one interesting. They only want PhDs with a science background, but they also want somebody who knows how to edit. So again, we have the combination of skills.
Okay, then chemistry. Who doesn't like to blow things up? And all the cute, catchy titles, Stacy. So I can't remember. I think I wrote one. So chemistry, we actually got to do a lot of chemistry the last 3 weeks. It was a lot of fun. The GC mass spec that Tracy mentioned, we saw some examples of NMR. We talked at the different industries. They talked about using different chemical processes to build maybe new drugs or using a new method to make a drug, to make a chemical. And so enzymology and chemistry can be very important in drug development in general, and we saw some examples of not just biologics, but we heard about examples, for example, at Bright, we heard about, we talked to some chemists who were basically taking chemicals that were known and then figuring out new ways to make them, or new ways to make them better. And so you have to have pretty good chemistry chops in order to be able to look at a compound and say, how can I make that, and what can I change to maybe make it more active than the compound that I have. And so several of the companies, including BTP Therapeutics, we learned about those kinds of processes and then taking them forward into development. And so just to give you an example, here's a job from Pfizer, and the thing that struck both Stacy on this one is they specifically mentioned non-PhD for this one, but they want somebody with an enzymology or biochemistry background for this position to work on discovery and preclinical development of oncological therapeutics. Again, just another example. Biology, osmosis, the diffusion of osmium across the membrane. When I saw this one, I thought, oh, perfect. But we saw a lot of examples of biological techniques and skills for everything from learning how to run a gel to learning aseptic technique, either in a microbiology lab or a cell biology lab, working with cells in general, to getting organisms to make a product we want. Now this is green fluorescent protein, which we all think is pretty cool, but we also saw examples of pharmaceutical companies getting CHO cells or E. coli to make a product for them. And then even at Carolina, we got to visit the live organisms that they're basically culturing so that we can use them in our classrooms. And all of this takes biology. Again, here is a job with, this one's for microbiology, and they want someone with a strong microbial ecology background, preferably relevance to agriculture. It's a senior scientist position. They're going to be working on some of the microbiome studies that we saw when we were at Novozymes. Then we also wanted to talk about soft skills, because everywhere we went, in one form or another, people talked about the importance of soft skills, either from the standpoint of specific ones or just in general. So one of the soft skills is collaboration.
We'll go through these. So we really enjoyed the collaborative spaces that we saw at WFIRM and Joint School of Nanotechnology and Data Engineering. It was mentioned at Carolina Biological that the thing that has helped science education more than anything else is collaboration. So we wanted to emphasize that. And again, so this is the exact same statistician position, and lower down, develop effective collaborations. So all of our jobs that we're seeing want these soft skills on top of their technical skills. Next, we have communication, more Hemingway, less Shakespeare. We don't need the flowery language, but we need to be able to communicate, right? One of the best quotes I've seen from Lee Iacocca, you can have brilliant ideas, but if you can't get them across, your ideas won't get you anywhere. So again, emphasizing the ability to collaborate or to communicate respectfully, but also effectively. So this is a scientist position. Excellent communication and organizational skills are absolutely essential. And then last,
Problem solving and critical thinking skills, again, this is something we saw a lot of places. And it can be as simple as figuring out, how am I going to run an experiment? How do I need to design this experiment? To figuring out how am I going to put beneficial microbes on a seed so that they will help the plant grow when it gets going. And then, so here's a quality control position where they're saying they want someone who who's developing or demonstrated troubleshooting and problem solving skills.
I'm out of time, but
Yes.
we had a little bit on how to connect students. So again, getting them to own it. I would say just go to the,
Yeah.
So Pfizer and their own it mentality, that really resonated with us. I don't know if you have anything else you want to say about that.
No, just getting the students to own it, give them the chance to own their work, and even if it's just within class, present what they have discovered.
Thank
Thank you to everyone.
I think we got everybody. And questions.
Thank you. Next up, Sayrd and Nakeisha.
And major photo cred to Patty and Alvin.
Also known as Ebony and Ivory. So, we're here while you guys hopefully. We'll see what happens. Give me 1 second. I'm going to post it up.
So I'm Nakeisha Robinson. I wanted to thank everyone for coming. We were part of the BIFP program, Bioscience Industrial Fellowship. The motto that they used was where passion meets purpose. And I'm an instructor at the College and Career Readiness Program at Biotech. And one of the things that I took away from this experience was connecting community with industry. The students that I have are either high school graduates or students who are getting their equivalent. And part of what they come in with is either experience in the workforce already. And one of the things that I wanted to bring back is the idea that even if you're not pursuing science, you can still work in the science industry. So as I'm working with my students, many times they're not really sure if they are doing academics, they're not really sure which way to go. So one thing that I found is this will give me a chance to expose them to the world of science and make it less intimidating for them. And then in the workforce part of it, if they are already working, many times they have some skills or experience that can be used to help them learn more skills to get into the bioscience industry. So one of the things is, as I was telling people about this program, and I noticed that when I talked to them about I'm going to go do this bioscience industrial fellowship, many of them didn't want to engage me in conversation. I don't know, maybe it was just the fact of hearing bioscience and them not knowing, they were not very comfortable talking about it at all. But as the cohorts began, and I would come home and they'd ask me, so what you do today? And telling them about what was going on. And it was like, oh, like the light bulb was going off for them. And it was a really good thing for me because we want them to come and join this growing industry, okay? So I noticed that they just got a little bit more comfortable, and then they was able to apply some of the concepts to things that they experience. Like I have a friend who is in the food production industry, and I told him during our industry visits, I realized that that was where my buzz came, like, and it was funny because many times the industries are very restrictive on what you can do or what you can see, but I found myself in these industries thinking, oh my gosh, I can't even contain myself. Like, you know, the ideas and the possibilities of who can work in there and who you're working with was just so exciting for me. And so I wanted to bring back to my classroom the idea of what bioscience is and make it to where they understand that it's not this arbitrary concept that you got to be smart as Einstein in order to be in it, you know. So what I want to do is kind of break down the branches of study that they do, and that way that they'll know. So we all kind of know about the environmental health and environmental sciences. But then the thing was, well, how do we use bioscience? So I was talking to them about different little things that we do, like food processing and agriculture. We use bioscience for the packing and the shipping of foods. We use bioscience in technology and engineering. We all have phones. This generation is really technology savvy, so this is a really good thing. And then of course, medicine and pharmaceuticals. And we all have someone who's been affected by medicine or pharmaceuticals. So the thing is that I learned is that in bioscience, you have to work together in the sectors of government, academia, and industry. But I also wanted to bring in this concept of community because sometimes my students are either they're in the workforce or they are in academics. Or maybe they're not even in either one of those and they don't see themselves as being part of those sectors. So when I said connecting community to industry, that's really what I was going with, was the idea of if you have an interest in science, or if you have attention to detail, critical thinking skills, analytical skills, you have what the industry needs. So don't think that you're not a contributing member, you know. And I also wanted to talk to them about the education requirements in bioscience and the fact that all education levels work within this industry. This is an $86 billion industry with 3,000 to 5,000 jobs expected to come in the next 3 years, and this is one way that we can get them in. So I intend to create more opportunities for students to collaborate with each other, provide more hands-on learning, and exercise critical and analytical skills. We were talking about, in my program, when I'm working with my students in the science, unfortunately, we just push reading skills. But if we had a way to give them 3D models so that they can look at what they're reading and feel it and touch it and see it and really know what it's about, I'm thinking that, you know, they'll be more engaged. I had a chance to work with everyone. Thank everyone for working with me. I'm a math head, so science was not my thing, and I thought the first day, the first thing that I said was, this is why I don't bake. I don't have science hands. But everyone was very patient with me. Some in particular were even more patient than others. And I found myself saying, wow, if we as educators make science this way for our students, then they will come. You know.
My name is Sayrd Price. I teach high school biology and earth environmental science at the Early College up in Stokes County, a little bit further north of here, near Hanging Rock State Park, which has excellent trails for mountain biking and running, which is primarily what I like to do. The first day, or first couple days of this fellowship, we were told by Dr. Herr, Dr. Reed, about how important stories were, all right, in the industry, okay? These stories, I'll tell you a little bit about myself. I grew up on a 100-acre farm, good old Fancy Gap, Virginia. I'm one of the few that we would say fell off the mountain. So I'm here now. I really appreciate being here. This is an amazing opportunity. I want to just thank you for that and being here at this time. So at Stokes Early College, the cool thing about this is we have fast-track educational support system. Students are getting their high school diploma and their associates at the same time. We have learning environments with minimal interferences. We have very small knit community, as Nakeisha was talking about. This is in a lot of ways a family environment. Okay, everyone knows everybody, from freshman to senior and beyond. No extracurricular activities, unfortunately. Band, sports, we don't have that, so we branched out. So we've got a garden club. You may be able to see that picture right there. We're working on that. We're working with various organizations to get that up off the ground, and we're also working to create a STEM club, or a STEAM club, okay? And this was one of the opportunities for me to expand on that doing this program, trying to find those resources I can bring back to my school, and also offer countywide professional development to promote those activities, okay? So, as Nakeisha mentioned, we have community leaders, government, mixed with industry, education. Obviously, you know, we're from education. The cool thing about Nakeisha and I, we're kind of like grouped one way or another through Forsyth Tech that has brought us all here together today, which is amazing. And as far as the family concept, I may teach students that their parent or grandparent, Nakeisha, will work through with. Okay, so we're seeing a multiple generation concept here. So the idea is to educate the public of what we have to offer. And that's what we're here for today. So, coach up, don't beat down. A lot of you guys may see this in the classroom. Okay, I'm a big promoter of that. Positive reinforcements, okay? Failed first attempt in learning, okay? Know that. If you don't, appreciate it, okay? That will make you grow so much more. A quick story. My brother, I have two brothers who are twins, and on the farm we had a pony that had a foal. The day before, we're going out to the farm to feed the horses, and we're walking out there. One of the brothers goes up to the new foal to see what it's all about. The foal's a big, small pony. Okay, and he's checking them out. We all kind of walk away towards the barn, get some feed, and we hear, what's going on? And we realize the pony, the mother, okay, had picked up my brother. He was about 4 at that age, and picked him up by the side and started going like this, just go like a little pit bull. We were like, oh my gosh. Okay, so a big first attempt at learning right there for that poor young man. I always wonder, like, as an adult, if he's enjoying an adult libation at one of the fine establishments, people are like walking around and talking about scars. They're like, oh, shark bite, bear, and he's like, oh, pony. Amazing pony bite. So it's very interesting how that goes about. Purpose with principles, okay? In the classroom and outside, we're trying to find this internal drive for everybody. Dr. Herr talked to the first couple days about what our internal and external passions were. He talked to us each individually about what we do outside and inside of our careers and how that pushes us forward, okay? Energies, that was a big thing, a big concept at Pfizer, okay? So mind, body, spirit, and how that conveys, okay? From yourself, you're emitting this energy, how is this affecting each other, okay? Cost is a big factor too. So we have to figure out how can we get from like that prototype or that discovery part that we've learned with medicinal drugs and so forth to the actual pill form, okay? What's the cost of that? But it's also not just in a money form, but it's through energy that we exert ourselves. So we're trying to find the balance, that pure flow of life, okay? Anybody know what that is? What's it? Yes. Yeah, monoclave, yes. Right there. I had a lot of fun taking pictures too, obviously. So champion the catalyst. Does that sound familiar? Okay. NC Biotech, we toured over there and they mentioned champion the catalyst, and I was like, that got me thinking, what do you need to have as far as these future learners? Okay, they need to have inspire creativity, active listening, build partnerships. That's not only what we do, but we want them to emanate that as well. Okay, as civil servants, we try to put that out there, but we want them to be the next generation to create that. Okay, to pass that forward. Anybody know what that is? Gel electrophoresis. Okay, good, good. I do a fun lab where we do foil and we do M&Ms and we coat them. We have a little bit of fun. Anyway, all right, get on track. All right, so Dr. Murdoch that came in earlier, introduced himself. He on day one he talked about crucible, how this building itself is a crucible. Okay, it incorporates stories, diverse learners, skills. All these things are being shared throughout. We want to create that everywhere. Okay, and within the classroom and beyond. All right, and that's success. Okay, people have different ideas of success. This is one that we've seen time and time again that will succeed anybody in their career, family, and in general. Okay, anybody know what that is? Yeah, yeah. So right here you got the tubes and labels and stuff. All right. Feedback for faculty. So the idea here with Nakeisha, she's going to provide for SciTech the professional development. I've got a countywide professional development, so I will inform our faculty and amazing colleagues throughout Stokes County about what this program offers. I found out about this program through one of my colleagues. Mr. Cass Stevens was here previously as well, so that kind of steps forward to it. SIT, our school improvement team. Okay, we learned a lot about through NC Biotech and also Pfizer, and even the nanoscience as far as the type of cultures they're trying to harness. Okay, either whether it be like the IBM concept of having learners trying to figure out what other people are doing. It could also be cascading goals. Okay, you're going one and then to the next. We're trying to build upon that and create a learning environment, the school itself, with a knowledge of bioscience and an appreciation of that to continue. Okay, Pbl Project-Based Learning. Okay, the good thing about this is, in a lot of ways, this is what we did today. This is what we're exemplifying what we've learned. Okay, cross-curricular. Obviously, we're going to tune in with various subjects and go from there. Biosciences has a plethora of information there, and it ties into everything. Okay, especially when you're talking about reading, literacy, and so forth. Okay. Anybody know what that is? Yeah, this is W Firm. You'll probably see this to the other people who got pictures of this because it was really cool. So the valve in the center there, pretty interesting stuff. Student support. This is the big thing right here. This is what I really push for. We mentioned literacy, field trips, awesome, wonderful ideas and resources I found throughout these 3 weeks is where we can take kids. Terry, this gentleman over here, has been a huge success on that. And the opportunity to be on the bus and learn the stories and resources from these fellows has been a huge success for myself and wanting to bring that into the community. Field trips, I've learned a lot of various places that allow field trips to get these kids in this first-hand experience, see what's going on. Summer programs, okay, excellent resources for that. And then best practices, we're already referring about soft skills, okay, general lab management, general practices, understanding that, getting kids to have those hands-on engagements so they know where it is going to be happening in the real world for their possible careers, okay. Okay, guest speakers, obviously we have some wonderful people in this room that have also offered up possibilities of coming to our classes, okay, and offering what they know, and that's so much better. Because sometimes I can talk all day, obviously, and my students will be like, oh, here he goes again, with a weird pony story, okay? But I'm like, no, we got so much to tell you. All right, so bringing all these other resources in is so beneficial, okay? Let's see. I think the best thing I've learned in this experience is the experiences that my fellows are having, and then also to learn from people that have been in the industry, especially academia. I guess, how would you say it? I wrote it down, I'm trying to figure this out. Mr. Woodruff over here, also known as, I would like to call you the Grand Poopah, if you will, of the educational part here. And then also we have Denise Schweitzer. She's like queen of content, all right? So it's kind of cool how we have been able to bring these people together and their excitement, okay? I love that because I try to build off of that too. I want to say I appreciate that. Do we have any questions or comments?
I have a question.
Yes, sir.
What kind of camera rig did you use to take these pictures?
That was just my phone, and then I did an Aviator app. And then the hipster
Editing
filters.
post.
Yeah.
Nice, right?
Yeah, some of those pictures, I was like, wow, that's a really good picture.
Thank you. Yeah, I have a lot of fun with it. Yeah. Any more questions, comments?
When are you gonna put the pictures on me?
So I did do a little top secret thing. So I took all these pictures. I would not post them on the band or little app because I was like, somebody's gonna steal it for their presentation. So I was like, all right. So that was kind of like my little incognito bit. Let's see.
Thank you.
Thank you. So next we have Nini and Jean.
Okay, so we are Team LIU All. So that's our version of Long Island University here in North Carolina. I hope you get it. But I'm gonna start. My name is Jean Molina. I have a background in plant evolution. I'm gonna get it started. So you might be wondering why I have Nini speaking in there. So. I'd like to thank her for telling me about this workshop. She was the one who introduced me to the bioscience workshop back in January. She told me it's about biomanufacturing. I was like, okay, that's not clicking. What does that really mean? And so I looked at the website. I emailed Russ to learn more information about it. It said, you're going to learn about industry practices, drug discovery, exposure to other next generation sequencing platforms, all of these cool things. And so I said, okay, that sounds cool. Please sign me up. So in LIU, at Long Island University in New York, we have a master's program in biology. And so I have to maintain an active research program for my thesis students, including Nini. So what I want to focus on really is how the BIFP experience will make an impact in my research, and how this will make me a better mentor, teacher, and researcher along the road. So one of the cool things that I work on from my research, and I probably mentioned this a few times throughout, is this beautiful, beautiful plant, Rafflesia. So it produces the largest flowers in the world, as you can see. This is not the biggest. It can grow up to 3 feet in diameter. And just fascinating biology. So really interested in its evolution. Always wondered, why it has become so big. And then it also stinks. It's considered a corpse flower, so it stinks. It attracts flies for pollination. But another cool thing about its biology is that it is a parasite. So we don't normally think of plants as being parasites, but here it is. So it's parasitic to this vine right here, but it's an innocuous parasite. So tetrastigma, the host plant, has no economic use. We don't know why, of all plants, it chooses this one. We're trying to figure that out as well, using genomic data. So back in 2014, we published this paper in Molecular Bio and Evolution. We had next generation sequencing data. So we tried to assemble the chloroplast genome because it is a plant. So we tried to assemble the chloroplast genome. We couldn't, but we were successful in assembling the mitochondrial genome. So, what's going on? And so we titled our paper Possible Loss of the Chloroplast Genome, which is unprecedented in plants. And so now what I'm trying to do is try to corroborate these results. So now I have additional sequencing data, transcriptome data, and I brought it up with Jason before an email. So I plan to collaborate with him on this one. He probably does not know much about it yet, but I'm looping Jason in here in IQ. And another aspect of Rafflesia biology that I'm also interested in is that it's horticulture. So Rafflesia is considered the panda of the plant world. It's rare and endangered, but unfortunately has not been propagated or cultivated out of the wild. And despite multiple attempts since the 1800s. Okay, so there's something going on. And I've been collaborating with the U.S. Botanic Garden for the past three years. So they've been funding me to go to trips to the Philippines to collect host material as well as Rafflesia material and bring it back here to the U.S. Botanic Garden up in Washington, D.C. So far, we've been successful in growing the host plant, and now we're trying to infect that host plant. Okay, and we have seeds. Well, I have seeds. The seeds are about the size of a pinhead, and I've done all kinds of in vitro germination experiments, exposed it to different types of hormones known to man. Nothing worked. And so when we went to Novozymes and they talked about their microbial seed treatments that enhance plant growth, that lit up a bulb. It's like, hey, can I buy that? So when we went back to the hotel, I emailed them. They told me, unfortunately, we don't sell to universities. And so that was a bummer, but that's okay. But I'm also trying to do metabolite profiling of the host plant, try to figure out, what metabolite it's secreting that actually attracts Rafflesia, that germinates Rafflesia. And so my plan is this August, go back to the Philippines again, collect host material, and then bring it back here in IQ. I've been corresponding again with Jason. So fortunate to know this guy and to be introduced to this guy because he has expertise in these kinds of things. So we're going to try to work out the details on how I can use their LCMS here in IQ. So I'll be back. I'll be back here. And so that's a potential collaboration with Foresight. And another aspect of my research that I'm working on is herbal medicine and drug discovery. So I was really excited, that we visited Pfizer, BTV. So that made it clear in my head, how the drug discovery process is. So I've been doing some research on this, but mostly on medicinal plants. So in the 3-4 years that I've been teaching medicinal botany, so I've learned that many of our pharmaceuticals actually come from plants. So if you think of digoxin, which is a heart drug, aspirin, morphine, even the diabetes drug metformin, or even Chantix. Have you heard of Chantix? Smoking cessation drug. I was surprised that that came from a plant, and they discovered that through traditional medicine. So Russians have been smoking that. So I felt like, one way we can accelerate the drug discovery process is by starting to look at, these natural products that come from traditionally used medicinal plants. And I've been integrating that in my research. So my background is plant evolution. Back in 2015, I had a student who was really interested in herbal medicine, but she only had 6 months to finish her thesis. So I said, okay, so let's do this. So what we did, being in New York City, so it's like a microcosm of the world. So you have, diverse cultures. So what we did was went to different herbal markets, cultural markets, made a survey of the different plant species that they use. So we have African herbal species, Chinese herbal species, Latin herbal species, and so forth. And we came up with this evolutionary tree. So this is an evolutionary tree right there. The colored lines that you see here, these represent the different cultures. Okay, so like pink is Chinese, red is Islamic, and so forth. These are the different herbal species. We have about 100 plant species in this phylogeny. And then we've also mapped on the phylogeny their medicinal uses. So what are the uses of these plants with respect to the culture? Okay? And the goal really is to find evolutionary patterns that underlie herbal medicine. Okay? So are there certain plant groups that are repeatedly used by various cultures for the same ailments? Okay, so I figure that this will allow us, to find patterns that can aid drug discovery. And in fact, we actually found, several plant families that are used by different cultures for the same thing. Okay, and this is what we call cultural convergence. So like just these different cultures converging on closely related species. Okay, for the same medicinal use. So these were the 10 plant families. I'm not really going to go through all of them, but I'd like to talk about the last one, Burseraceae, which is the frankincense family, just to elucidate, I think the importance of this. So we have here about 5 species used by different cultures. Again, the different colors here represent the different cultures. They all belong to this plant group, Burseraceae. And then here, like when we did the survey, all of them are using it for musculoskeletal problems. So that makes you wonder, why? What is in this plant family that makes it useful for this purpose? So like, pain, arthritis, anything that has to do with musculoskeletal ailments. And then I started digging up in the literature what they have in terms of pharmacology. If you look at the Boswellia species, what I found out in the literature, they contain triterpenoids called boswellic acid. Okay? And it turns out to be very potently anti-inflammatory. Okay? And even the paper says that it is hyperanalgesic. So really incredible pain-relieving properties. Okay? And then I also looked at another species, Comifera, which has been used by another culture. Same thing, similar phytochemicals, not exactly boswellic acid, but very similar, okay, in terms of chemical structure. And again, they were talking about anti-inflammatory. And these are like separate studies, okay? So it means that this process is allowing us to predict, what could be present in closely related species. So if we have other species that have not been explored, but they are within Burseraceae, then we can predict, based on evolution, that they would have similar phytochemicals that are anti-inflammatory. And when you think about it, so I think this was quite interesting. When you think about it, one of the most common anti-inflammatory that we use is hydrocortisone. And you can clearly see the similar chemical structure. And so probably the hyperanalgesic effects that the paper was talking about may have something to do with this chemical group. I don't really know. But this was, something very exciting for me. So, hey, we can probably start testing these natural products in a pharmaceutical setting. But that part, I don't know, because I only have the theoretical, so I did not really have any industry partnership or that kind of thing yet. Okay. And then more recently, we also published this paper. This was just published in February with a grad student, Emily Guzman. So what we were looking for here are plants in the literature that have cardiovascular properties. And again, we look at it from an evolutionary standpoint. So we have here the evolutionary tree. We mapped on the right their mechanisms of action. So which plants have calcium channel blocking activity. So calcium channel blockers, they are useful for hypertension. So if you think about it, calcium is needed for muscle contraction. So deprive the blood vessel muscle of calcium, then it will not contract, so that will alleviate hypertension. Okay, so we have some plant families that just show calcium channel blocking activity. Members of the ginger family actually show that. Members of the carrot family, fennel, dill, parsley, they also have calcium channel blocking activity. In fact, one of our pharmaceuticals right now for hypertension is amiodarone. Amiodarone was derived from a relative, so from a species within the carrot family. So I find that very interesting. So, but what I'm trying to say here is that we can look at these natural products, okay, as a starting point, as drug leads, and then test them. And that's the reason why I was so excited when we went to Bright, because they have the whole drug discovery pipeline. And so after our visit in Bright, I emailed this guy, Dr. Rob Onyewonti. He specializes in the high content imaging and also high throughput screening of natural products. And I said, I sent him this paper. I told him what I do, and he said, hey, that's very interesting, because my expertise is calcium channel blockers and stuff. We could collaborate, email my PI. And so that, I was so excited when I heard that. Again, I'll be back. Well, we'll be back. So that's why I put right in here. I'm going up to my last slide. This statement right here, how can North Carolina help transform you? I stole that from Nancy Johnson's PowerPoint at NC Biotech. I just want to reiterate that the whole 3-week experience was really transformative for me. I liken it to pottery being made. I'm the pot, the being sculpted, and I feel like the whole experience just transformed me into a better researcher, mentor, and teacher. And I would sincerely like to thank Russ for giving me this opportunity, Patty, Mary, and my co-fellows for making it a transformative experience for me. Thank you so much. And now I'm going to transition to my partner here, also from LA, Nini Fan. So she's going to talk about the BIFP experience and how that can help in establishing the CRO in LIU, so Contract Research Organization in LIU. And if everything goes well, she might be my future boss. So I'm going to lend her my expertise in whatever capacity she wants me.
So hi, I'm a Nini fan, as she just introduced a lot of me, and I would like to focus on how this BIFP experience fellowship program helped me tremendously in terms of gaining insights and inside and outside of the bioindustry. So, and especially from academia to discovery, research, down to online to manufacture, development, launching, or commercial, the whole thing, and we have to see it through all of it. This is just really great, and so I would like to talk about more stuff that's going towards the industry and commercialization. So probably not going to focus on particulars of academia, and but this is also enhance collaborations, and as the first group mentioned, soft skills is really important. So my background, I have a Master of Science in Molecular Bio, and I did a cancer research, and also I have an MBA degree. So as some of you might know, I'm a die-hard entrepreneur as well. So let's talk about, this is the transformation from CRO to industry. And we are, so what CRO is, just in case people don't know what it is, it's a contract research organization. So basically is contract is we can outsourcing a lot of stuff with different areas like biotechnology, preclinical trial or clinical trial, medical device, anything. And it also could be varied in different specific areas, such as just specific phage. And what our core is trying to build is a core facility, but based on genomic center. So everything that's involved with genome and genetic and stuff. So this is our core facility. So currently we have run some stuff like genotyping, next generation sequencing, and bioinformatics, and then some PKPG simulation for different drug toxicity, and that based on different outcomes for a different person. And so just for another background information, our school line at university is really famous big pharmacy, and our school president is really focused on how to develop research and how to develop pharmacy. So this is us right now, and we are a CRO, and what we try to do is more going towards the gene-drug interaction discovery, and down to the line, and which is my passion, is to figure out how to fit in this to a molecular testing way to everybody. And so right now we're focusing on 3 keys. To start with CRO, we are going to train our students, employees, or even people who can come outside from their companies, and our students could be varied as high school, college, and grad student, for example, like me. And researcher, what we have done in-house, more like a microbiome. We can do barcodings, and we do a lot, and obviously Professor Jean Mayer here, she's doing plant biology and evolution, a lot of stuff. And hopefully this is going to transform it to human genome very soon. And also, I would like to say this core facility is the central dot of academia and industry. So we are basically can do this whole consulting firm that's introduce students to come in to work on hands-on, like even machine learning or technique learning and everything, to provide the services so they understand, have a good set of skills to go to industry. And as many of you might know, New York City is not so big on technology. We have a really limited space. So being here is just crazy, and then you guys have a the big pharmaceutical and biotechnology space, and definitely want to bring this back. And this is the research I've done just a little bit. My research was on metagenomic sequencing, 16S RNA. So the research I've done was collaborated with our school of team of pharmacy, and his research is based on natural product, how they have effects on chemotherapy and different areas in the cancer stuff. And what I did, or part of this stuff, is to sequence the gut microbiome to see the changes of how they use DDS to Cladis and how they induce Greek powders. So this was the dedication point of my science background, that I'm definitely going into the genome part, and this is the area. And as some of you might know, I've been to a NASDAQ I-Corp, is the NASDAQ funding program for training scientists to discover their novel discoveries. And we had to do 100 interviews, and that is missing a picture here. That is how I met Russ last year, and then he invited me to attend a stem cell genetic medicine workshop. That was also something that just brought me back here. And then how I passed down to our colleagues to emphasize this is a great place that we can be. And then just want to briefly talk about the experience that we have been through. This is basically all the logos that we have been through this past 3 weeks, besides the DH. One. And then I will definitely love to have further collaborations with all of the folks. I know my time's up, but especially shout out for Dr. Bell. He was really inspirational in terms of teaching and in the classroom. And so that's us. and foresight, and we're definitely going to do more collaborations with Jason, innovation quarters, and right, and how she mentioned how the whole drug discovery, and then I'm pretty sure I'm going to be coming back here, and then another shot. What really blew my mind was obviously Doppler Pharmaceuticals and how they made organelle on the chip, and how they implanted 3D technology into the surgery. It can recover wound fast, and yeah. So I always have the heart of trying to. I guess my passion is more than just science and genome. It's more than it's about how to transform those science, knowledge, or powerful things to individual people one day. And then I guess that's it. Yeah, just want to go through this, and then want to thank everyone, especially Ross. And then it's really great to have you as PI in leadership and mentor, and Mary and Patty, they're so they beat us everything, and all of us. And then I don't know, this is probably one of the best group, like 10 people we are. And then just want to say we make a really strong great team, and then we can all collaborate in the future. And thank you all.
Next we have Tiffany and Alvin.
My name is Tiffany. I teach biology at Hope County High School in Rayford, North Carolina. So if you don't know where Rayford is, I always have to say, oh, it's near Fayetteville, North Carolina, or Fort Bragg. So I came based off of Jason's recommendation because I did a PD workshop last year through Bio Network. So he introduced me to this program. So it's kind of like the anniversary of me emailing Dr. Russ that same day he told me about it, because I was like, oh, I'm excited because I love PD. So the thing that I wanted to do was figure out how do I get my colleagues involved, and also getting students involved. So demystifying that biotechnology myth in my community as well.
Good morning. My name is Mr. Alvin Antonio, and I'm a third generation teacher. So my grandfather is a math teacher for 14 years. My mom is an English teacher for 26 years. And I've been teaching for the past 24 years now. And I've been teaching in the state for 11 years in the state of North Carolina. I'm teaching at Clinton City Schools, and I arrived here in 2007 and I became an exchange teacher through the BIFP program, or the BIFP International Faculty Program. So after why I really want to be a teacher, because I think being a teacher, that's really my passion. So I think it's run also on our bloodlines about that. And in fact, my wife is also a science teacher in New Mexico. And for the past 11 years, I'm about to leave the state of North Carolina and teach and follow my wife. I'll be a science teacher at Gallup-McKinley County Schools to serve our Native American students there. So that will be a new journey for me. And I think this will be part also of my teaching career. So the things that that we learned from this workshop, and we are very fortunate that the National Science Foundation funded this program through Mr. Ross, and Mr. Ross invited me for the past 2 years about this program. And since I'm also working with Summer Ventures every year, so I think it's about time, and since it's also fit with our schedule this year, so I said yes to Mr. Ross. And I think one thing that the program did to me is I became more effective because of these programs that we experience right now. And I've never been in a multi-billion company that we've visited for the past 3 weeks. At the same time, also learning different core lab skills that we had on this program. So, and probably after this workshop, so we have something to share also with our students. So, just to give you first an overview of all the things that we learned, the things that we experienced for the past 3 weeks. So during the first week, since we started, we don't have an idea, okay, what are the things that we will be doing on the workshop. So we went to different company and different community college that we have. So during the first week, we went to Forsyth Tech Community College, wherein we also did some core lab skills like PCR and gel electrophoresis. We went also to Rowan Cabarrus Community College with the instructors there, wherein we also learned about HPLC. Okay, and at the same time, we are very amazed on what they set up on the David Morda Research Institute, wherein we've seen the biggest bioreactor that they have here, with regards to also for the human health that they're using. And this is my first time I saw a transmission electron microscope and SEM, where I only seen this through pictures, through the web, through the help of the connection of the Joint School of Nanoscience and Nanoengineering. At the same time, we also seen different drug manufacturer who are also doing the phase 1 and phase 2 with high point clinical trials, at the same time the BTV therapeutics. During the second week, we went to Pfizer, and this is our first time to encounter different gowning technique, because in our class, every time we talk about aseptic technique, so this we mean, okay, wearing a lab coat, wearing a mask, and putting a surgical gloves. But there's more than that. These are the things that we learn, and I think you can see in my picture. Sorry for my big belly there. Okay, so that's me. And so gowning in this drug manufacturing, is really very difficult to do, especially on my case with my weight treatment. Especially, I have experienced difficulty in wearing the boots there, so I can reach my foot at the same time. So wearing a double layer surgical gloves and all that suit that we have there, I think it took probably around took us 15 to 20 minutes before we do the things that we need to do there inside. So we experienced how we manufacture drugs. So I think they mimic something like a process on how to do it on the real time. Then at the same time, see, this is also the things that we learned in the Capstone Center in Raleigh. Then we also learn different concepts in WFIRM. So we've seen the artificial heart wall, or the
tricuspid valve.
Yep. And also the kidney that they're using at the same time the bladder itself. So, and the last week we went to Nova Science, then Bright. So we also learned different lab skills from Pbl with regards to cell culture in Alamance County Community College. Then we also went to Carolina and Biogen, which is also a drug manufacturing company, which also share us the different methods with their pipelines doing different drug manufacturing processes. Okay, so biotechnology, it is, I think, one word that we used to discuss in class with our students. So basically, every time we talk about biotechnology, it pertains about the using of organisms or their products for commercial purposes. Through biotechnology, which is also the things that we share with our students, that the reason why we can discover certain drugs to treat genetic disorders is because of biotechnology. So it's also used mainly for diagnosis, not only for human health as well as animal health when we talk about cell itself. Okay, and Tiffany will talk about.
All right, so we oriented this PowerPoint because we're going to take it back to the classroom and show our students. So the first thing when I do biotechnology, I show my students crazy pictures of like glowing mice and a person with 6 fingers, because getting a grasp of what is biotechnology and not a whole bunch of words. So looking at this, about 80% of our food production is through biotechnology. I have a picture of the Advil because I learned at Pfizer that, hey, that's where we make a lot of our drugs, pain medications, and they're actually starting the gene therapy there, which was kind of great. I added a picture of here so kids can kind of see, oh wow, so this is what's going on at W firms, kind of like a myth to them. Wearables, so I think this is really cool for the future. And corn, because that was one of the first biomanufactured food products.
Okay. As an educator, I think one thing that we are trying to give more importance is the future for our students. I think that's the most important thing. I think the reason why we are here is because of them. In the industrial setup or industry setup, so they call it the customers. So our students in the education setup is our the students are our customers. So sometimes, every time they attend or take a science class, they're always thinking first that the science is so hard, so difficult, I cannot pass this class. That's why we're trying to motivate them, okay, and trying to push them how science is really an awesome class, okay. And one thing that we also apply in class is through lab skills, because nowadays students learn not only through lecture, but they learn more on interaction. They are more on collaboration. They learn more on hands-on activities. So like on my case, I really love doing lab in my class besides lecture. So this is the main concept that we formed with Tiffany.
All right, so the whole idea that I took away was culture, embedding culture, and how these industries were all about culture. So when we visited Pfizer, they talked about having a culture atmosphere. Also, the Joint School for Nanoscience, they talked about culture, so embedding students and relationships with the industry as well. So here, does anyone know what this picture represents? Yeah, this is spiderweb. So I incorporated this because I came and I, like my Oprah moment. Okay, so this is what this is. So we started small, worked our way up to the industry as far as packaging. So we started small with the lab skills. So I thought about a spider web and how a spider weaves a web. And so I embedded culture into, because I am Native American, so I did some research and looked at different cultures. And some cultures, such as the Plains tribe, they believe that spiders are scary, all right, they're dangerous. All right, and some tribes, such as the Osage and the Blackfoot, think that spiders they're patient, their endurance when weaving that web. The Blackfoot, they think they're intelligent and skillful. So I embedded this into, wow, this is what biotechnology is. Some people still believe that there's a stigma with these stem cells, as we discussed with Dr. Rufus at his lab about stem cells, but now we are going into looking at not using embryonic stem cells, but also adult stem cells and mesenchymal stem cells to do research with. So we're kind of demystifying that area, because in the public sector, we don't even talk about stem cells in the classroom. So how do I lobby? Because Russ, he kind of put that title on me, so I'm going to lobby to kind of maybe help change the curriculum. How do we embed these new incoming technologies into the science classroom, because our standards have not been updated since 2009. So how do we change that culture of, embedding biotechnology more into biology in the classroom and getting students motivated and involved to work in these industries that we visited, because there's some I didn't even know existed until I went there, because I know Novozymes, they said we don't put our name on products, so I didn't know it was there. From a small county. So my job here is to, how do I partner with some of these industries and kind of give my students time in their labs, such as that community lab at Biogen. So creating internships for my students is what I really want to bring back to my students. Because I actually did an internship at NIH, but had I not been in college, I would have never known about internships. So, kind of weaving that web while they're still young, getting them intrigued in science is what I want to take back. So culture, education, and kind of steaming that into industry. But we wanted to stick to the educational side, because, talking to kids about industry is a little bit above their head, but if we can kind of streamline them into the right colleges, and thanks to us for setting up this program, we were kind of able to see, hey, these are the schools that offer internships that will get you into these industries.
And we also share with our students the main role of education in choosing a career, because sometimes most of our students, especially in our county, Samson County, we have 80% of our students are reduced lunch. So I always tell them that having a career is more than flipping a burger. So I want them to dream big. I want them to, think outside the box. And through this workshop or this program, we are now trying to share with students that through an industry, through biotechnology industry. So you can also part of the biotechnology workforce, whether if you are not only a science major, as well as an English major, or probably a math major at the same time, okay, based on all the things that we experience.
So we added this little picture, and everybody should know what this is by now, right? Because a lot of people are interested in this, so the bioreactors. So I'm going to change the name of my classroom, and now you're entering the bioreactor. So it's a human bioreactor, because we're going to get our students to do what? Learn about biotechnology and spew that information out to maybe their fellows. And so we embedded some soft skills, so working with others, managing information, thinking, problem solving, being creative, self-management. So kind of weaving that into a pattern. So thinking about how do I need to set my classroom up was a big takeaway from here. So embedding stations, so having students move. So like we did as we moved from one place to the other, from one lab to an industry. So doing that whole station rotation, getting students to understand, okay, so you need these small skills, now we're going to move up to the big pharma and embed that into the classroom. So we think the main goal to all of this is inquiry-based learning. So going more to inquiry-based learning, getting students to be more creative, think outside the box. Because if we didn't have scientists that were not creative, we wouldn't have all of these inventions and vaccines. All right, so this is just a run through of what I'm going to tell my students. Hey, these are the tracks you need to go through your starting with 9th grade, 10th grade, 11th grade, 12th grade track towards the science. All right, so if we have students that are getting ready to graduate and they don't want to leave home, like I didn't leave home. So if I didn't leave home, I didn't get the experience, these schools that had connections to these industries. So my school didn't really have a strong biotechnology industry connection. So here are some options if they don't want to leave home. So based on the schools we went, we had the opportunity to visit these schools. We said, hey, here's some schools where you can get an associate's in biotechnology and undergrad and grad at these universities. And I was able to get a PD at July 29th at Bright, so I signed up for that PD. So getting my colleagues to say, here are some PDs that are locally that you can get involved in, and also Dr. Woodruff at Alvin. All right, so I'm going to give the students a list of the educational fields. Here are some fields you don't have to have only science, but mass communication, statistics, as Stacy mentioned earlier, engineering, language arts, being able to build, manipulate things, because without, bioreactors, you have to have what? Those pipelines and those plumbings to go from one bioreactor out to the aseptic hoods. So it's a lot of work.
Okay, one particular thing that we also learned through this program is making connections, and through different programs that we have that we visited. So they gave us also an idea that to share this with our students.
All right, and so here are the overview of, here are some areas that we can say, hey, we can use this in the classroom at BioNetwork, because I have never used the online simulation, so I thought that was great. I can take this back to the classroom. Bright is another way, because they actually have student workshops as well as teacher PD, and Biotech is kind of like, getting lab experience to the industry experience.
Okay, on the next slide, so to give you also an idea what are the different lab skills or core lab skills that we learn through this program. So through the 3-week programs that we have, so we've done different lab skills on different community college. So like the pipetting or micropipette technique, PCR and gel electrophoresis, we also did this in our workshop. Well, we have HPLC that we did, and the BioNetwork Capsule Center. Aseptic technique that I mentioned before. Cell culture through Elements Community College. DNA sequencing, wherein Sir Jason also shared it with us during our first week. The gas spec and the mass spec from Ms. Denise there at the back. okay, who share about all this concept about things. And thank you very much, Ms. Denise, for sharing that your expertise from Rowan Fabulous Community College. And through the Capstone Center, we don't know that in a lab, we don't need this. So first thing that I realized that you need to sign every time you did something step by step. We learned that through Janet and Annette from the Capstone Center about batch production record, or the BTR.
Okay, so as an educator, this is what I plan to do: incorporate lesson planning into station rotations, modeling for soft skills, making sure that students know those, lab techniques, again, methodology, taking advantage of biotechnology resources, and writing grants because we need money and funding for the classroom. That's it. Thank you, and thank you, Dr. Russ, Patty. That's it.
Okay, to end this presentation, we want to thank Ross, okay, for having this program. It's really opportunity for us as an educator that we learn a lot, and we are now ready, okay, to share this with our students, to our community. At the same time, to Dr. Green, Dr. Morgan, okay, Ms. Denise, Ms. Mary, who are very helpful to us, Ms. Patty, okay, our host companies, the multi-billion companies that we visited. Thank you very much for this, for giving us a chance to see your wonderful, your awesome bioreactors that you have there. So to our instructors, to our co-fellows, and National Science Foundation, you're really awesome. So you gave us this money, okay, to experience everything that we need to have, and the National Center for Biotechnology Workers. Again, thank you for an awesome experience.
Brian and Terry, last but not least.
So I'm Brian Gadd, and this is Terry Howerton, so we're going to share with you about our experience over the last few weeks. Just some brief background on myself. I have a strictly academic background. Coming into this, I have a PhD in cell molecular and developmental biology, which means I spent a lot of time in a research lab and absolutely no experience in industry, so my ignorance is showing, which is exactly why I'm here. I have a lot of teaching experience. I was a TA for 6 years. I've taught at a number of different community colleges and liberal arts institutions, and was recently hired as a full-time faculty member at Los Angeles Mission College, where I'm teaching non-majors general biology as well as the cell and molecular majors course. And we just started up a biotechnology program. I had nothing to do with that, but I'm hoping and would love to be able to teach some of those courses in the future. And because I have strictly a background in research, this program to me was particularly exciting because it gave me the opportunity to get some experience and some insight into things that otherwise it would be really hard to teach about because I just have no experience.
I'm Terry Howerton. I'm a coordinator and instructor at the biotechnology program at Atkins Academic and Technology High School here in Winston-Salem. Atkins is a STEM magnet school, so we have students that choose to come to our school and major in either biotechnology, health science, engineering, game design, or scientific visualization. So the students that I teach have sort of chosen at least a path at this point. I've been teaching there for 13 years. I've had 26 years of teaching in the classroom, so I can see the light at the end of the point. And so I wanted to be part of this program so that I can learn more about biomanufacturing, so the skills, the opportunities, so that I can take that back and share with my students. Just a little bit about some of the classes that I teach, because I will mention those later. I have a freshman class that I teach, Biotech 1, where I introduce them into biotechnology, and we do some lab skills, so they'll learn about keeping a notebook, they'll learn about metrology, solutions math, they'll learn some equipment, microscopes, spectrophotometers, gelotophoresis, chromatography. And then in the second level, we get into some more molecular, cell molecular, so cell culturing. We'll do some gene cloning and DNA manipulation, some downstream processing. And I'm, again, just trying to introduce them to these concepts.
So one of the things coming into this is my limited experience, a very generic sort of view on what careers in biosciences might look like. So pharmaceuticals or biopharmaceuticals or agriculture, things that might have come to mind, but I don't know that I've given a lot of in-depth thought to what this would look like. And of course, if I'm trying to interest students who are non-majors in science in general on things they can relate to, or my major students on what they might be thinking about as possible career stuff later on, it was really good to get the wide variety of exposure to different corporations and different sides of the biosciences industry here. Right, so for example, I never really thought about things like Carolina Biologicals, a company that I use all the time, as that's part of that industry, right? Supply. Or regenerative medicine. For me, that was a really cool theoretical thing when I was in school, and not something that I ever thought about as now we're moving into the manufacturing and production side. And so it was sort of changing my mind and thinking about what this would look like and how I want to share these things with students in the future. And then, that's all in good, but I have a huge number of non-majors who come through who have some passing interest in science. And okay, what can you do if you're thinking about a career, you're not going to be a research scientist, and you know that, and that's fine, but you might be interested and you might want to know what you can do that might be related. So a lot of the companies we went to, were telling us about some of these potential things, right? So you got to be a strong writer. We need people who can write. You don't have to necessarily know all the science about it, but you might be more apt to be interested in writing for this company because you like the science, or you like that you're involved in that, right? Or having business skills, right? Carolina, all these people have advanced degrees. They're all going back to get MBAs so that they can improve the way that their company runs. Being able to do the boring stuff, right? Certain people have different personalities, so doing IP and regulatory. Computer science, huge, right? That's one of the things that's like the not so secret big thing up and coming is, can you get a student who just loves computers to say, hey, there's a biological side to this and that might interest you, and sort of expand that. Graphic design, marketing, communication was huge. I think that one of the best tours that we got was at Biogen from somebody who was not a scientist at all, but was a great communicator. So, especially at a two-year institution, I have time where I try to talk to my students. You get a feel for, their personalities and what they might like, and sometimes you make recommendations. Hey, you should check this out. You should think about this. So I think this helped me on that side of things as well.
All right, so as I talk to my students, sometimes I try to give them this sort of models of the bioscience industry model competencies that would help someone be successful in this industry. So I thought this might be a good way to help focus sort of what we've learned and some of the takeaways we've had. And so, again, it starts with the bottom of looking at personal effective competencies. It moves into academic competencies, and then workplace competencies. And above that, then you probably get into things that are more management. So we're going to sort of use this to jumpstart our rest of the conversation.
So our program's kind of divided into some major different areas. We visited a bunch of different companies, but one of the other key things we had were these boot camps where we looked at a lot of the different types of techniques or skill sets that were necessary. So that was really valuable. Some of these are things that I'm very familiar with from research, but I may not have any idea about how they're applied in industry, or I might be able to do a column TA big, but I have absolutely no understanding about scaling that up and what's involved, or to be able to communicate that to students. So that was really important for me to realize the significance of some of these skills, that they're still relevant, they're being used, and to contextualize that for students, I think will help tremendously as far as getting them to understand what these look like as far as careers in the sciences.
So some of the takeaways for me as far as changing my instruction. So in my freshman class, I start off the year with having learning about biotechnologies and industry applications. I have them to write a biotechnology entrepreneurship grant. They get to fund themselves for some innovative grant, innovative drug. And so as part of due diligence, they have to research some major companies, some of which were Pfizer, Biogen, and Novozymes. So for me to be able to go here into these companies now, this gives me so much more passion, so much more information. I can share with them stories, I can show them pictures of me gowning up, and so I think I can help make that unit a much stronger unit. Also in that same course, I've been trying to teach a little bit about CGMP and regulatory practices, and I have them do a batch record. I've never done a batch record, so it's sort of been academic for me. Now I understand what goes into a batch record, and so I definitely want to rewrite that one. In my Biotech 2 class, I do some downstream processing, but after having gone through the process of the Biotech, I now will definitely make that stronger. Things with cell culture, I want to add cell culture, I want to add next-gen sequencing content. There's just a lot of things that we've experienced in this boot camp that I definitely am going to find ways to bring into my classroom.
So there's the skill set side of this, whether it's techniques or the math. A lot of what we heard wasn't necessarily from employers like directly about the skill sets per se. There's some background that's necessary there, but it was really interesting to see how much emphasis was really placed on soft skills by employers. That was something that was pretty consistent across the board. So for example, Pfizer or Piedmont Animal Sciences, they had very obvious and obvious, I mean like on the walls everywhere, sort of dedication to culture in the workplace, right? So Piedmont Science has these giant pirate flags all over their walls, right? Because they're fostering this culture of being disruptive, where Pfizer's own it. And I think a lot of that is sort of linked with this notion of teamwork. It was amazing to see how much teamwork really played an important role. So being a team player, it really stuck with me, and I can't remember the gentleman who gave us the tour at Pfizer, but his comment was, the first thing was a little humility was going to be really important. It's something that he couldn't teach, and that's something he needed coming in, and that was going to be really important to play a role as part of the team. We had to work under strenuous conditions in ridiculous gowning to fill at BTech, and we had to coordinate to do that and to do it well. So I think that was like a hands-on practical. It's not only like, okay, I understand that this takes teamwork, but I think it was, for me, reinforcing just how important it is, and I feel like I'll do a better job conveying that to my students because of that. Bright is training students to head into the biosciences, and it was interesting to note that in their curriculum, they have an entire course. I don't know what's in there, but it's titled Teamwork Environment. So those things really stuck out to me. And then of course, we've got 10 of us in a van running all over the place for 3 weeks. And that was another one of those like, okay, like we got to work as a team and these sorts of things. It really reinforced it for me in a really good way.
Yeah, some of the things I picked up, like critical thinking, and really making sure that I get my students plenty of opportunity to look at the data and think through that. So we heard stories from BIFP about how to looking at their data for their phase 2 clinical trials and how they're going to how to massage that and think about that and where they go with that. We had Alvarez giving us some case studies and presenting some scenarios for us and asking us to make some decisions. So obviously that's an important skill. Communication, gosh, whether it's written communication with lab notebooks or batch records, whether it's listening and talking. And we heard about, the challenges of chemistry and biologists getting together and having to speak each other's language and enough where they can get some things accomplished. Integrity. I think some of us showed a little lack of integrity when we were counting up because we stepped across that line of clean step back. And so if you're doing this in a real situation, you have the integrity to say, I messed up, or integrity to say I didn't actually do that when someone asked me to sign something on the batch record. And again, things that maybe aren't always innate, but kids can learn if given an opportunity to understand why that's important. Persistence. Pfizer and some other times we heard that there were hundreds of steps and hundreds of tests just to bring a single dose to market. And so helping kids to be organized, plan, and attention to detail, and that this is not going to be an immediate gratification in its career. And then finally, flexibility. The regulations are going to change, the products are going to change, and sometimes the company is going to change. We heard of a person who had worked for 8 different companies and never had to go to a different place for work because there's always mergers. So those are some soft skills. Now the challenge is that many of us work in an environment where what's valued is test scores, right? And so we push hard. We don't have a chance funds for labs. We don't have an opportunity to take time to build these in. So my challenge is for those of you listening who have a voice with Raleigh or the state or local education, if this isn't what you think is important, that maybe you can give us a little help as educators on talking to those who set policies so that we can make sure that we are providing the workforce with the best possible raw material.
So some takeaways on our end as far as instructors. When we were at the joint school for nanoscience and nanoengineering, I never remember the full names. Dr. Hare said a couple things that really resonated with me, and I know a few others as well. One is tell it with a story. He did a really good job of doing that by telling it with a story. And that's something that is sort of always on the forefront of my mind, but it's not necessarily very well done. So I think that was kind of just another one of those good reminders of, hey, this is something you really should be incorporating, because it was one of those things that really made an impact on me. Incorporating informal education, this also really resonated with me. I had a student last semester who started making all kinds of connections between what we were learning about pH and his job, because he tests water quality in pools, but had no idea why he might be doing certain things. And that kind of stuck back there, and it really came back to my mind when he was talking about informal education and the experience that people have. And so, something I really want to do is find a way to really kind of tease that out of students and to get them engaged with the course. I love making stuff up on the fly every semester, and inquiry-based or problem-based learning is definitely one of the better ways to get students to learn material. And so just the experience that we had in Nova Enzymes gave me some ideas for some exercises I want to do with students. It was really great looking at sort of this big biology picture, right? Like microbes and agriculture, and how do all these things connect? And I could see how we could really use that as an example to get students drawn in for some of these concepts in my non-majors biology course. At Bright, I had the opportunity to talk to a couple of medicinal chemists. I'm obsessed with this structure function thing, and I'm always looking for better ways to convey that to students. And so there were some great examples of structure function that the medicinal chemists gave me some ideas to work with. So I look forward to working on those with my major students. Again, I'm more or less ignorant on the bioscience side for industry, but I feel less ignorant now. I feel like I can teach these in the future. I feel like I've got some fundamentals to start building off of.
And again, as far as improving my craft and improving myself, I'm supposed to be a leader in my classroom. Hopefully I am. But one of the things I learned, even with all the regulation, which you would think would be a top-down, way of leading, I still feel like I got a lot of input about bottom-up. How can we help you be better at your job? And that reflected on me that I need as a teacher to sort of take that approach. And I get caught in the traps of trying to get through the curriculum and trying to get the best test scores. And sometimes I don't have great emotional intelligence. I don't listen to my students as well. So I need to focus more on listening to them. I need to self-assess for myself and to help my students learn how to self-assess and ask, why are you doing what you're doing? What are your strengths? What are your weaknesses? And then whenever we have a victory, help them to celebrate, because that's obviously, you saw that throughout all of the companies, is celebrating what they did well. So with that, I'd like to take an opportunity to thank a few people. Again, thank this NSF for providing opportunity with this grant, and also to thank Russ and Denise for writing the grant, but also all the work that Mary did to make things happen, the emails that she sent out, often multiple emails to me because I didn't respond right the first time. Getting us to the right places, Patty driving, I'm sure she missed a few of the potholes on 40.
She was trying.
She was trying to, getting us there, making sure that we were here on time, and so it was a great experience. So thank you for that.
Yeah, thank you guys, especially those who ran the boot camps. That was great. We really appreciated that. The companies, if you're watching, we can't thank you enough. We know that takes a lot of time, and we don't see that necessarily, but we definitely appreciate that. And our fellows, thank you guys. You made the last 3 weeks a grand adventure. It was a lot of fun, and we got a lot out of just talking to each other about being educators. So we appreciate that. Thanks, guys.
Wow, good job, everybody. Good job. That's great. We're at that point now where we actually graduate you. And then, so what's between you and lunch is graduation. I think you've heard a lot of thank yous, and, my staff, I want to really thank Mary and Jason and Patty for coming on board. And obviously my co-PI, Denise, is great. And my longtime friend, Bill. And Nancy in the back there too. I mean, it's just a huge collaboration to make this happen. And so, thanks to everybody for doing it. And John's like part of the team. He's over here always helping us. But, most important and first and foremost, again, a big attribute to the National Science Foundation Advanced Technological Education Division for letting us do this again. So, we are at graduation time, and Mary has diplomas there, and I'm going to ask the faculty and our friends, the staff and industry partners to line up here, and then we're going to call you up. And guests, if you've got guests, please come on up, and we're going to get you through the graduation. Come on, Mary, you announce names.
Thank you. Terry Howerton.
Jason, come on. Nancy.
Congratulations.
Congratulations, Terry.
Sayrd Price.
Congratulations.
Alvin Antonio.
I hope you know her.
Great job. Thanks. Wonderful.
Congratulations. Thank you. Tiffany Dow. Congratulations. Brian Gadd. Bring your wife with you. Stacy Diva.
Congratulations, Sarah. Great to meet you finally.
Nini Van, also known as Little Mama.
Oh, yeah. Okay. Oh, wow, great. Thank you so much. That was good.
Nakeisha Robinson. Jean Molina. Congratulations. Last but not least, Regina Delrovich. We'd like to thank you for participating and hope you all enjoyed it.
Yeah, let's get a picture.
Quick picture. This lunch is that way, but we want to get a picture of you.
I don't do that. Yes, you do.
Come on over here. Mary, you want to put me in the picture?
Yeah, I did. Come on, guys, bring your stuff.
Hurry up.
Let's have a group picture.
Yeah, who's gonna get close? Come on, Pat.
Everybody.
Get in the picture.
Inclusive picture front.
Blue mama and there she go.
How do you want a picture?
Come right here,
Even
Nini.
John can be in the picture. Hold your
Come on, guys.
Okay, we need a good one and then a crazy one.
This feels like my stint.
Not going back.
Okay, now everybody jump.
Please don't jump.
We're trying to kill us.
Okay, crazy now.
Yeah, that's right, that's right. Okay. That's for you, just for me a note, and I'll make sure you get connected to the. Thank you. I'll get it in a second. Okay, sure. You can hand it to me.
You got to go about what?